Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Resonance structures of polycyclic aromatic hydrocarbons, PAS, are drawn by distributing the pi electrons, double bonds, in all valid kekulé-type arrangements where every carbon has a valid valence and the structure retains alternating single and double bonds. Anthracene consists of 3 linearly fused 6-membered rings sharing 10 pi electrons, 5 double bonds, across 14 carbon atoms, with 10 carbons in the ring framework contributing to pi system, actually 14 carbons total, 7 double bonds in the full structure. Let us count properly. Anthracene has the molecular formula C14H10 with 7 degrees of unsaturation from the ring system, meaning 7 double bonds must be placed in any kekulé structure. To enumerate valid kekulé resonance structures of anthracene. Structure 1, double bonds at positions 1 to 2, 3 to 4, 4A, 9A, 5 to 6, 7 to 8, 9 to 10, and 1 bridging bond. Systematically, one places double bonds such that every carbon is satisfied. By systematic enumeration, anthracene has exactly 4 valid kekulé resonance structures. These can be derived by considering the possible placements of the 5 double bonds. The C9, C10 bond can be a double bond or not, and the remaining double bonds fill in accordingly in the 2 outer rings. When C9 is equal to C10 is a double bond, the 2 outer rings each independently take one of 2 arrangements, giving 2 times 1 equals to structures. The outer rings are forced once C9 is equal to C10 is fixed, but each outer ring has 2 options, actually yielding to structures here, both outer rings in same orientation or alternating, but due to symmetry constraints only 2 are valid. When C9, C10 is a single bond, each outer ring has 2 independent kekulé arrangements, giving 2 times 1 equals to structures. The middle ring must have its double bonds at C4A, C8A and C9A, C10A positions. Total, 2 plus 2 equals 4 resonance structures. Why other options fail? A. 6 overcounts. Naphthalene has 3 resonance structures, and anthracene does not simply triple that. B. 5 incorrect enumeration. No valid 5th kekulé structure exists for anthracene. D. 2 undercounts ignores the valid structures where C9 is equal to C10 is a double bond and the 2 outer ring configurations. Therefore, the correct answer is C. Therefore, the correct answer is option C.